Welcome back to Tomorrow's Investing. In today's video, we'll be diving into the fascinating world of advanced packaging for chiplets. Chiplets have revolutionized semiconductor technology, offering increased flexibility, scalability, and performance. Let's explore the different types of advanced packaging techniques used for chiplets and their pros and cons. In this video, we will be looking at the 2.5D packaging, 3D packaging, wafer level packaging, and fan-out packaging. 2.5D packaging. 2.5D packaging involves stacking multiple chips or chiplets on an interposer or silicon substrate. This technique enables high-speed interconnects between the chiplets while providing a smaller form factor compared to traditional packaging. Pros of 2.5D packaging. This type of advanced packaging provides performance with shorter interconnect lengths, improved thermal dissipation due to interposers' thermal conductivity, and allows for heterogeneous integration of different chiplets. Most important con is it involves higher cost due to additional interposer manufacturing and integration steps, and limited scalability compared to 3D packaging. 3D packaging. 3D packaging takes chip stacking to another level by vertically stacking multiple layers of chips or chiplets. This approach significantly increases the integration density, allowing for more complex systems in a compact form factor. On the pro side, 3D packaging provides greater integration density, enables more functionality in a smaller footprint and shorter interconnect lengths, resulting in improved signal integrity and performance. It also enables heterogeneous integration and co-design of various chiplets. Disadvantages are that it increases thermal challenges due to the vertical stacking of chips. It also requires higher complexity in manufacturing and assembly processes. Therefore, there are potential yield and reliability concerns in stacking multiple layers. Wafer level packaging. Wafer level packaging involves embedding multiple chiplets into a single wafer, which is then diced and packaged. This technique offers high throughput, cost-effectiveness, and improved electrical performance due to shorter interconnect lengths. Wafer-level packaging is cost-effective due to simultaneous packaging of multiple chiplets on a wafer. It has shorter interconnect lengths, resulting in improved signal integrity and performance. It also enables high-volume production and scalability. Cons are the limited in terms of scalability compared to 3D packaging, yield challenges due to potential defects on the wafer affecting multiple chiplets, and design restrictions imposed by the wafer-level integration process. Then the last type of advanced packaging we will discuss in this video, fan-out packaging. Fan-out packaging expands the chip area by redistributing input-output connections on the package substrate, enabling higher input-output density. It provides more space for interconnects and offers improved electrical performance compared to traditional wire bonding. Pros of fan-out packaging are increased input-output density and interconnect space for chiplets, improved electrical performance and signal integrity, and fan-out packaging enables miniaturization and form factor optimization. On the con side, there are reliability concerns due to the redistribution of connections, higher manufacturing complexity compared to traditional packaging, and increased cost compared to wire bonding techniques. And that wraps up our exploration of advanced packaging techniques for chiplets, including 2.5D packaging, 3D packaging, wafer-level packaging, and fan-out packaging. We've discussed the pros and cons of each method, but it's important to remember that there's no one-size-fits-all solution. The choice of advanced packaging technique depends on the specific requirements and constraints of the application at hand. In the future, we will be diving more into these techniques and which type of packaging will be the best suit. Thank you for joining us on this journey today. We hope this video has provided valuable insights, and make sure to check out our playlist on chiplets. Don't forget to subscribe by clicking on our logo displayed to make sure you don't miss out on any future technology-focused deep dives.